swimmer's itch. And so the question became one of higher resolution. We needed higher resolution and more specificity in our testing to be able to answer bigger questions and more important questions. So we decided that we wanted to design qPCR tests that would let us identify between these different species of parasites in a water sample. So we asked the question, can we do that? And so we sequenced, got the gene sequences for a whole bunch of those parasites. We compared everything together. We compared against a whole bunch of different parasites that were found in water. And eventually we got to a point where, yes, we could design qPCR tests that allowed us to detect T. stegnicolae, T. brantae, T. oscillata, T. ficeli, and this helosoma parasite that seems to be kind of unique. And the only place where we had a little bit of cross-reactivity was with the T. oscillata assay, where it also cross-reacted with Trichobilharzia zedae. What this allowed us to do is design monitoring programs with people, probably some of you in this room, that would then tell us, well, are mallards contributing most of the lake? Are mergansers contributing most of the lake? Are Canada geese contributing most of the lake? And that's because we know the parasites that are going through those birds. So we can design high-resolution tests for these different parasite life cycles. And now this year, we took those tests and we said, well, let's see what we can get with this. So Ron and Freshwater Solutions, with a bunch of you guys, I'm sure, put together what I think is pretty much the biggest community-based monitoring program for a water sampling testing, certainly for swimmer's itch in the world. And it's a very comprehensive testing program. So this is what it looks like. There are 16 lakes in Michigan that are involved. There's at least 10 sample sites per lake. Some sites are sampled each week. We have 2 U of A coordinators, myself and Sydney, who Ron introduced you to. We have 6 Freshwater Solutions program managers, and there's over 25 community partners collecting samples. Samples were collected from May to November, so we're not done yet. We won't be done for a little while still, but we will collect over 1,000 water samples. And that means that Ron is going to have run in his Freshwater Solutions lab over 1,000 of those general schistosoma assays. And then what we're going to do is we're going to take the ones that are positive for any schistosome, and we're going to run a species-specific test on it. And we're going to run all species-specific tests that we have, all 5. That means that we run over 5,000 species-specific qPCR tests at our lab in the University of Alberta. We've run about 2,500 already, I think. And just to give you an idea of what that looks like, this is just some data from that program that we're starting to see in a heat map form, where we have sample collection date on the bottom axis, and then we have the site at the lake on this axis. And then the color moving towards red means you just have more parasites there. And so what we have this broken down to is this is species A, B, and C. This is not analyzed enough for us to give you the nitty-gritty details on this, so I don't want to talk about what it is or what's going on here, what lake it is or anything. But what I want to show you is that there are some locations that we have really high abundance of parasite species A, but very little abundance of parasite species B. That's pretty important. And if we take that same heat map and we just color code it based on the species and we merge them together, what you start seeing is that the locations that are black are places that have all of the parasite species, all 3, at that location. But if you have a color there, red or green or blue, which that's the only place, then that means you actually will have only a single parasite species contributing to that location at that time point. Now that becomes really cool because then you can start putting together questions and hypotheses. You can say, well, at this date, June 4th, 5th, we have very little swimmer's itch on any day. Why did we have very little swimmer's itch on that day? Because it doesn't make sense. Because I-9, this is the peak transmission point for I-9. We have a ton there, and nothing there. So what's going on there? Is the wind blowing away from the collecting site on I-9 at that day? Is there something else environmentally that's going on at that site during that time? That's a question we can ask if we collect all the right data. And then at I-15, you look and we have only one time point where we actually have any swimmer's itch at that time point. So if I was to say, where am I going to swim on this lake? I'm going to I-15. So this lets you start tailoring programs and things like that just based on this raw data. This doesn't even have any analysis involved in it at all. And the only way we would have gotten this data is that we have 25 community-based partners collecting samples weekly at this lake from May until November. And we're going to answer questions about every single parasite species that causes swimmer's itch to that lake. And that's the scale and scope that you are afforded by having a community-based monitoring program. This would never have been possible. There's no way that Freshwater Solutions would have been able to do this And the only way it happens is with that sort of trickle-down effect of having partners in the community that are helping do some of the science. So, the pan-swimmer's itch test allows us to find areas where there are high concentrations of swimmer's itch causing parasites. This is our general test, right? So we use this as our first screen for swimmer's itch. But then the species-specific qPCR test allows us to distinguish which species are causing itch at a site. Performing those tests using qPCR allows us to unify all those tests around a single method. So that single sample that was collected serves as the template for the pan-schistosoma assay and all the species-specific assays that we run. So we use one water sample from each site for that whole thing. Simplifying those methods and eliminating the interpretation, which comes along with qPCR, really helps make this an appealing approach for CBM. Because if we use qPCR, all you have to do is isolate the DNA, follow the cookbook recipe, and then the qPCR machine gives you a value. You, as a user, don't have to interpret anything. You get a value, that's the value. There's no interpretation. You don't have to decide what that value means. You just get it. That's the value. So there's not any interpretation, which for those of you who've done Secchi depth using a Secchi disc, you do it, and then your buddy does it next to you, and you might come up with a meter difference in your Secchi depth, right? Somebody maybe has, you just can't see as far down as the other guy. So we think that using CBM, the way we just showed you in the qPCR for the swimmer's itch, that allows you to really expand the scope and scale of monitoring efforts. And I think that swimmer's itch story really exemplifies that. That's one lake that we have that for. We have 17 lakes in this study. So we're going to have ridiculous data on swimmer's itch. Okay? So I want to talk a little bit about now enteric bacteria. This is where I think a lot of people are here for. So I'm going to draw this analogy where here's our pan swimmer's itch assay, and then when we get positives, we go down and we do these different species-specific assays that allow us to get better resolution. Now, enteric bacteria monitoring works in very much the same way. I would argue that we based this approach to monitoring swimmer's itch off of existing source tracking approaches for enteric bacteria. Enteric bacteria, from a qPCR monitoring program perspective, you're typically monitoring for one of two different bacteria, either E. coli or Enterococcus. There's a long history for why you monitor for those, and I want to make sure that I try to keep close to on time. So we'll talk about that later when somebody asks a question about it. But usually what happens is you'll run a water sample through an E. coli or an Enterococcus test, and then if it exceeds what we call an action level, you would then run what we call a source tracking test. And the source tracking tests, which are also qPCR assays, allow you to take that same sample and then say, oh, okay, do we have human contribution of fecal material? Do we have cow contribution? Do we have goose contribution, gull contribution, dog contribution? There are lots of different source tracking tests that you can run for enteric bacteria. And they are usually well validated because every one of these tests was designed and validated by somebody at the US EPA. Okay? So they go through a very rigorous testing protocol. Now, where I am in Alberta, we run the Enterococcus test, and there's some reasons for that. One of them is that the Enterococcus test correlates slightly better than E. coli for enteric disease development. So if you exceed an Enterococcus guideline, you tend to have a higher correlation with that then leading to enteric illness in a person swimming at that location than you do with E. coli. So that's why we use Enterococcus. In Michigan, you guys use E. coli, which is fine. Don't worry about it. The question, though, is do you exceed regulatory action level or guidelines? So we have two different thresholds. We have this action level, which is lower, and then we have the guideline, or the regulatory level, which is when you would actually have the state come and put a sign up at that beach saying, like, don't swim here, okay? And when we do a source tracking test, we typically use HF183 for human detection. We use rum2bac for cattle. We use dog3, Canada goose, so CGO1. We have a muskrat one because we have lots of muskrat up in Alberta lakes. And we use a seagull marker. And for Enterococcus, those source tracking tests would be triggered if you exceeded 640 cell culture equivalents, and the limit is exceeded if you have 1,280 cell culture equivalents. And this unit is in place because traditional testing has always been culture-based for enteric bacteria. And so what has happened is as qPCR assays have been designed for enteric bacteria, they've essentially tried to convert those values back to a cell culture equivalent so that you can compare qPCR values to entero alerts or coli alerts or an actual cell culture test. Okay? And what's important to note here is that when you do a source tracking experiment, you don't just run a whole giant panel of tests. You typically tailor your targets to what you think might be contributing to your water sample. So if you don't have any cows in and around northern Michigan, where you guys are near your lake, you don't need to run cattle. Because if your watershed isn't collecting cow poop from anywhere, then you probably don't have a cattle marker in your sample. And you don't want to waste your sample, right? Because you have only so much DNA. Once you extract the DNA from your water sample, you don't have infinite DNA. And so while you can run a lot of different tests, you can run out of those. And so if you run every one of these source tracking marker tests, you may not have anything left. So it's important to tailor it. So if you're looking at human connections, if you're at a beach and you have storm sewer outflow, or you might have septic systems contributing to your watershed in that area, you might want to run a human marker. And Canada geese, just so you know, these contribute like 50% of the poop in any poop sample in a recreational water context. So if you get a poop sample from a lake and you get a positive or an action level, it's probably half Canada goose at least. Canada geese poop everywhere. For those of you that have been near Canada geese, their poops are big, they're pretty serious, and they poop a lot. So I want to get into the weeds a little bit in Michigan, because Michigan actually has a very comprehensive beach monitoring program already in place. And this is something that if you don't tap into this resource just for fun, I recommend doing it because it's fun. This is from your 2018 beach monitoring report, but there's actually a website you can go to that you can download the history of every beach in Michigan for every test. You can see what test was done. You can actually see who ran the test, and you can get tons of cool information. Some beaches are monitored very heavily, and other beaches are monitored like maybe once every 2 years. So this is something to note. What's kind of cool though, I just summarized this data set over here. These are the inland lake data sets for 2018, and you can see it goes back a couple of years just to give you some comparison. There are around 200 inland lake beaches that are monitored annually, so if you consider that you have 11,000 lakes, that's a pretty small number of beaches comparatively. About 20% of those inland lake beaches have an action every year. The action means that they either did a source tracking test or a sign was posted. Some of the beaches have been actually closed for a number of days because of one of these actions. If you look down on this bottom part, which is telling us the reason for those actions, you can see that stormwater runoff is the most common known action for closing a beach or having an action elicited. So stormwater here, you can see you had 263 days of beaches affected by stormwater runoff. That's very, very typical in places where you have stormwater. That's going to be in places where you have municipalities, like Traverse City will have stormwater runoff that goes into the lake at that point. So you'll have many of the beach closures will be due to stormwater runoff there. But we also have tons that we don't know the reason, right? So they're only distinguished between stormwater, wildlife, other reason, which is only 3, and then unknown, which is the majority. And those unknowns could probably be answered to a much better resolution if you use source tracking qPCR to find out why they're giving you a fecal material sample. And the new system that's coming in where it is qPCR based, you start to see resolution on the website where these unknowns are starting mostly to be turned into gulls or geese, one of those two birds. And we also have some very prominent water researchers in Michigan, Joan Rose being one that's worth mentioning, that has done some really interesting studies on septic systems and rivers in Michigan. And so this is a paper that was published in 2015 where they took 64 samples from rivers in October, and they looked for E. coli, which is shown on the left, and then B theta, which is a human enteric marker. Now rivers, keep in mind, are usually catchments for a whole bunch of different places, and so you're going to tend to see highest enteric bacteria levels in rivers compared to lake shores and stuff like that. But you can see here, the red, greater than 5.6 log colony culture equivalents per 100 mils. These are places that have very, very high human impact, okay, in these river systems. And remember, only a single time point here, but when they then took the land use data and they looked to see the density of septic systems in each of these different regions, I'm assuming counties, sorry, I don't know, regions, watershed, sure. And then you map B theta concentration on the y-axis. You can see that for the places where you have high septic systems, you have higher B theta. Okay, so we know that when you have high septic system concentrations, it doesn't matter how old they are, it doesn't matter what the deal is, concentrations of septic systems correlate strongly with the presence of human marker in these rivers, at these watersheds. So I want you to remember this because I want you to start thinking about how this study could be improved if we had community-based monitoring programs in place to sample more routinely these places. Because is this the way it is in June? Is this the way it is in July? Is this the way it is in August or September? Is this the way it is at the spring? Because it could be very, very different. This could be a very different picture depending on what time of the year you sample. And so I think that's worth mentioning. So we do have some enteric studies that we've started. And this is data from Glen Lake, where we did an HF183 study, which is a human marker. And we just showed, we sampled, well, Ron and Freshwater Solutions and his team sampled a ridiculous number of sample sites around Glen Lake, okay? This is 146 samples that were taken around Glen Lake. So you have very, very good resolution here. This is a single time point, but you can see there are some places where we see some human marker in Glen Lake, which is totally not unexpected. The key now is that we can start thinking about how we build upon these types of studies to get very good resolution data about contributions of fecal material to the lakes. In Alberta, we have some similar studies, although they're not quite as comprehensive. This is a Lake Baptiste and Island Lake in Alberta. This might be a little bit harder to see, but these little blue dots represent positive sites that were collected and gave a positive for human marker, HF183. And these little areas where there's a bit of color added to that blue dot, that means that you actually have exceeded some sort of level of HF183 at those locations. Just so you know, there's a municipality on this side right here, and there's a municipality right here, and there's a municipality right there. And so we know that these municipalities are contributing significantly to these human source markers in this area. When we gave them this data, they asked us what they were supposed to do with that data afterwards, and I said, well, you can either tell the municipalities or you cannot tell the municipalities, but this is the data. And then we did a cattle source tracking marker in the streams, and there's a big cattle operation right here. And so you can see these are different dates. And so you can see that cattle operation contaminates many of the streams in the region. The streams are flowing out of this lake into a river that's over here. And so these streams are heavily impacted by cattle fecal material. And so you can start getting this kind of information using this type of an approach. This is sort of that A model CBM where the community was collecting all the samples and then they just brought them to us. But as we move forward with this now, we're going to get a qPCR machine to these people so they can start running their own tests. The point though is that you can start doing some really comprehensive testing. There's no way that this lake would do this on their own because just to give you a sense, in Alberta, if you were to contract qPCR testing, it's about $300 a sample to do contract qPCR testing. And then it's about another $50 per every additional test that you add off of that sample. So $300 for the initial qPCR test and then $50 for every other sample. So here we would have a single sample collected from each lake that we could build off of. So that would be $300 and then $50 for the ruminant marker. So $350 per sample. They have 2 different dates collected, let's say, and we have about 75 sites. So it adds up to over, I think it's something like $26,000 once you add it all up. Just to do this one study where all they would have really gotten out of this is that there's some fecal material, human fecal material around the lake at the municipalities, which that makes sense. And the cow operation impacts the streams that run through the cow operation, which I could have probably told them that was what was going to happen. But this gives you the actual data that you can use to do that. But this is a CDM project, so it costs them almost nothing. Because they're doing all the work, all the heavy lifting work, right? Rather than paying a contract company to come in, sample all this. That doesn't even include sampling, right? That's $300 just to run the qPCR. So the Enteric study for 2019 here in Michigan, which was a little bit smaller than our swimmer's ditch program, but that's to be expected. We're just moving this off the ground right now. We have a much more comprehensive enteric studies that we do in Alberta, but we have 7 lakes involved in the enteric study here right now. There's about 20 sites per lake, but that can be quite variable. And those sites are sampled at a single time point during the year. And again, we have these 2 U of A coordinators, 6 freshwater solutions managers, and about 12 community partners working on this project, which means so far we've collected about 200 water samples. There's been 200 Enterococcus qPCR tests, and we've run 400 tests at U of A for human and goose specific markers. And this is where we'd like to think there's a lot of room to build. And there's a lot of partnerships that can be made with enteric bacteria, I think. So I want to quickly do a little summary, and then I'm going to talk to you a little bit about our sort of longer-term visions here. So there are well-established protocols for using qPCR to monitor enteric bacteria. This is really important because for the swimmer's itch test, this is stuff that we've been working on as a research project. We've been designing these tests. So to kind of bring this into your question, you asked if there are these, much sort of really established SOPs that can be followed for qPCR testing. The swimmer's itch ones, we're designing those because we're the only ones that are working on this. And so we're designing these species-specific tests, and we have to kind of get those SOPs up to a place where we're comfortable with them. But for the enteric bacteria, these are SOPs that are designed by the US EPA. Okay? And they go through hundreds of thousands of reactions to validate these tests to make sure that they're able to correlate with what they need them to. But these source tracking tests allow us to have a very high resolution assessment of the origins of fecal bacteria at a site. And that has a lot of implications. The HF183 marker, or the human enteric marker, that's actually not used to detect human bacteria because we're worried about human bacteria.